What is the voltage across a 5 microfarad capacitor if the charge on one plate is 0.12 millicoulomb? How much energy is stored? Solution. So we have a given capacitance and the charge. So charge is directly proportional to the capacitance and voltage, where V is equals to Q over C. Substitute the value of Q and C. So 0.12 times 10 to the power negative 3 coulomb over 5 times 10 to the power negative 6 farad. To calculate 0.12 5 times 10 to the power negative 6. Okay. So that is 24 volt. Next, to find the energy, W is equals to 1 half times the capacitance times the voltage, which is squared. So substitute the value of capacitance and voltage. So 5 times 10 to the power negative 6 times 24 squared. So to calculate, so that is equivalent of 144 times 10 to the power negative 3 millijoule. Okay, so that is the final answer. Next problem, the voltage across 15 microfarad capacitor is V of t is equals to 10 cosine 6000 t volt. Calculate the current through 8. So apply this formula. I of t is equals to C dV over dt. Okay, so you can substitute the C and V. So 15 times 10 to the power negative 6 times 10 cosine 6000 t over dt. Okay. So derive 10 cosine 6000 t, that is equivalent of so that is 10 times 6000 times the derivative of cosine, that is negative sine 6000 t. Okay. So calculate And the result that is equivalent of negative 0.9 sine 1000 t ampere. That is our current. And that is our final answer. Again, negative 0.9 sine 6000 t ampere. Next problem. If a 20 microfarad capacitor is connected to a voltage source with V of t is equals to 50 sine 2000 t volt, determine the current through the capacitor. Solution. I of t is equals to C dV over dt. Okay. So substitute the value of C, which is 20 microfarad, or 20 times 10 to the power negative 6, multiply by the derivative of 50 sine 2000 t, okay, over dt. So therefore, this is 20 times 10 to the power negative 6. Okay. So 50 times 2000. The derivative of sine 2000 t, that is equivalent of cosine 2000 t. Okay. So calculate. So 20 times negative 6 times 50 times 2000. Okay. That is 2. Cosine 2000 t. Okay, so therefore the final answer is I of t is equals to 2 cosine 2000 t. So next problem, determine the voltage across a 2 microfarad capacitor if the current through it is I of t is equals to 6 e to the power 3000 t milliampere. Assume that the initial capacitor voltage is 0. So solution. In that problem, we use this formula. Okay. V is equals to 1 over C integral of 0 to t I dt plus V t. Okay. So we have given the capacitance to microfarad, and then the current also, the equivalent. Okay, so substitute the value. 1 over 2 times 10 to the power negative 6 integral of 0 to t, and then 6 e to the power 3000 t So take note that we assume the initial capacitor voltage is equivalent to 0. So therefore, this initial voltage here as 0. Okay, so we can now integrate. So this is 1 over 2 times 10 to the power negative 6. So times 6 here. Then take note that this is current is milliampere. So times 10 to the power negative 3 also. Then times a derivative of this, that is 3000. Okay, so 1 over 3000 times e to the power 3000t. So what is the equivalent? Okay, so calculate. Okay, that is 1. Okay, so 1 e to the power 3000 t. Okay, 0 to t. Okay, so substitute. Okay, e to the power 3000 t minus e to the power 3000 times 0. Okay, so take note, this is equivalent to e to the power 0, and that is equivalent to 1. Okay, so therefore the final answer is e to the power 3000 t minus 1. Okay, that is equivalent answer, volt. So that is the final answer. Next problem, find the equivalent capacitance seen at the terminal of the circuit. Okay, so the following given are 50 microfarad and parallel to the 70 microfarad, and then another is 20 microfarad, then 60 microfarad, then 120 microfarad. So the unknown here is the capacitance equivalent. So to find the capacitance equivalent, so okay, so take note that this is microfarad also. Okay, so for all the given, the units is in microfarad. Okay, so don't forget that the equivalent circuit in series, where the series of a capacitor, that is 1 over uh, CT total, or capacitance total of C1 plus 1 over C2. Okay, so therefore we start here to compute on the circuit, and that is easy way to do in solving this schematic diagram. Okay, so therefore to find the equivalent circuit of this, that is 60 times 120, okay, over 60 plus 120. Okay, so calculate 60 times 120 over 60 times 120, that is a plus. Okay, so that is 40. So this equivalent circuit is 40. So take note also that in parallel capacitor, the CT is equals to the sum of C1 plus C2. Okay. So therefore, this circuit is 40 microfarad. So in this circuit is 20 plus 40, that is 60 microfarad. Okay. So take note also, this is the parallel 50 microfarad and 70 microfarad. So 70 plus 50, that is 120 microfarad. Okay. So now the circuit is become a series. Okay. This is C required, or C equivalent. So this is 60. Then this is 120. So we all know that 60 times 120 over 60 plus 120 is 40. So therefore, C equivalent here, okay, that is equivalent of 40 microfarad. Okay. So that is the final answer. So next problem. Find the voltage across each as the V1, V2, V3, and V4. Okay. So first, in this schematic diagram, we have the given 60 volt, then 40 microfarad, 20 microfarad, 60 microfarad, then last is 30 microfarad. Okay. So we find the charge, or the Q, or which is the equivalent of the unit of coulomb. Okay. So to find that, first is we take this, the equivalent. Okay. So take note that in series capacitor, so that is 1 over CT is equals to 1 over C1 plus 1 over C2. If the capacitor is in parallel, so therefore the CT is equals to C1 plus C2. Okay, so to find that, we solve like this: 60 times 30 over 60 plus 30. So that is equivalent of okay, so 20. So take note that this is in parallel with 20 microfarad. So therefore, here is 40 microfarad equivalent. Okay. So again, 40 microfarad is series to the 40 microfarad. This in B1. Okay. Capacitance in B1. So therefore, 40 times 40 over 40 plus 40. So calculate. Again, that is equivalent of 20. Capacitance total is 20 microfarad. Okay. To find coulomb, we use this formula. Q is equals to CV. And then we have the voltage given. Okay, so 20 times 60 volt. Okay. and that is equivalent of 1200 column. Okay, so that is the equivalent of Q, or the charge. So check, let's check if it is 1200. So 20 times 60. Okay, so sakto. Okay, to find the V1, which is the voltage in V1. So take note that this is equal. So the charge is like an current in the resistive circuits. So therefore, in V1 is equals to the QT over C1. Okay, so where C1 nato here is 40 microfarad. So 1200 over 40. This is coulomb, then microfarad. So therefore, V1 here, to calculate, that is equivalent of 30 volt. Again, take note that in a series capacitor, the voltage is it will be add. Okay, so therefore this is V1 and V2, then the VT. So we're V2 here, that is equivalent of VT minus V1. Okay, so 60 minus 30, so that is equivalent to 30 volt. So we write here V2 also is 30 volt. Again, to find also the V3 and V4, we use the voltage division. Okay, so we use this voltage in V2. So where that is equivalent of 30 volts. So to find V3, that is equivalent to V2 times the capacitance of V4, that is 30, or we write the we write the formula first. So that is C4 over C3 plus C4. Okay. So V2 here is 30 volt. Then C4 here is 30. Then C3 here is 60 plus C4, which is 30. So calculate. And that is the equivalent of V3 is 10 volt. Okay. So another, to find the V4, we use also the voltage division. So V4 is equals to V2 times the capacitance of C3. Okay. Over C3 plus C4. Okay. So therefore 30 volt times C3 here is 60 over 60 plus 30. So to calculate B4, so 30 times 60 over 30, 60 plus 30, that is 90. Okay. So therefore, the V4 is equivalent to 20 volts. Okay. So that is the answer of the voltage across of the capacitor. First, V1 here is 30 volt, then V2 is 30 volt also, then V3 is 10 volt, then V4 is 20 volt. Okay, so regarding on voltage division, or to analyze the voltage division in capacitor, so for example, for this circuit, this is additional need to know no, about the voltage division in capacitor. So for example, this is ET, or the total, then V1, then V2, then C1, then C2. Okay, so okay, voltage division in capacitor. So when to find V1, so the formula of that is E1, or sorry, ET, which is the voltage total, times when you take V1, so you must take capacitance in V2. So therefore, C2 here, then the sum of this capacitance of V1 and V2, which is C1 plus C2. Okay. So when you take, or to find the V2 or voltage capacitor in V2, so you must take that is equivalent of the voltage total, and then you must take the capacitance in V1 here, which is C1 over C2 plus sorry, that is C1 plus C2. Okay, so that is the concept of voltage division in capacitor.